Friends, we are here to share the knowledge of each one of us. Everyone have worked on different projects, and I want to share my experience and our company's experience how we deal with this type of building. We are talking about a Widespan building. It's a HUSSAIN Bhavan in New York. This brings me to one of the important points, that how we got this project actually. We Phenix are only AISC certified PV manufacturer, and this was the prime requirement to get this project awarded to us. And if I talk about Phenix, we are having a manufacturing facility in Gujarat which produces around 70,000 metric ton per annum. And I'm very, very happy and glad to say and to announce that we are opening a plant in Tamil Nadu, HUSSAIN, which is very near to you, and we want to serve our clients in the southern part of India. We are going to produce around 40,000 metric ton per annum, and all the machinery what we are using, it is already imported from USA, Canada and Europe. We will be very happy to serve you, very close to you, sitting near to you, and it will be a very great experience for you and for us both. And Phenix is a part of M&B Group, a very small branch what are the areas where we can support you. One is the self-supporting steel roofing and industrial building, of course, we are expert in that, and bridges, roads, pharmaceuticals and hydrothermal power stations. Now let us straight away go to the case study. This is the Radhe Song Satsang Vyas, RSSB we call it. It is in New York. If you can see, this is the 3D photo sketch. It is 340 meter wide building standing on one central column. We will discuss more into that. It is just a picture, and let us go ahead. Who is the client? Client is RSSB, which is Radhe Swami Satsang Vyas. It is actually a religious organization spread all over the world, and they have existence in US also. That's why they want to construct this Satsang Bhavan in New York, and we were the PV manufacturer who were hired for this design and consultancy. Now the client's team is also very strong. They hired CNS companies, a consulting firm in USA with a team of professional engineers and structural engineers. But one thing is very unique here. Generally what we happen when a PV manufacturer, when we supply the building, the stability is under PV's vendor scope. But in this case, the design stability was with CNS. So they have went through a high level of checking. Even a one clip, one bolt, one screw, they did not leave, and they have asked each and every calculation because they were supposed to give the stability certificate. And there was one more consultant, SIFTech. There are the employees of this SIFTech consultant are the members of RSSB organization. So they were acting like an incline to us. So we are having two levels of checking. Let us straight away move to the project. What is the project? The project is 340 feet wide center. It is around 103 meter with one central column. We will discuss about the more challenges also what we have seen in the upcoming slides. Now the length is around 146 meters, clear height is around 6 meters, slope is 1:11, base spacing around 9.11, and design code is IBC 2015. It's not Indian code because the building is in US, the consultant is in US, the design stability was supposed to get from US. Of course, it should be an American code, so it is IBC 2015. Now, let us straight away go to the challenges. I'm very sure that at the end of my session, definitely we will learn something, each and every one of you, of us in fact. First thing, unlike typical industrial building, this building was supposed to be aesthetically good. So they have erased or they have omitted many of the things which are part of the typical PV building. The first thing comes first, main frame columns was supposed to design it pin based only in major axis, and while no wall bracing was allowed. I repeat, there is no wall bracing. Why? Because of course it's a public figure and people will be having full access, so they don't want the cross bracing, as well as portal bracing also was not allowed. So this was the challenge one of we faced. But how it is deviating from our conventional steel structures? If you see MEMA, the clause 1.3.6.2, which says roof acts as a flexible diaphragm, which means frames and bracings are then designed for two-dimensional model. What does it mean? the building in two directions, right? The major axis direction it will be taken care by frames, and the minor axis completely, or the length of the building, completely taken care by the bracing, roof bracing and wall bracing together. Now we are omitting one of the important one, which is wall bracing. Let us see how we cope up with that. Now the second point, the second requirement what they had is they want circular column in the middle. Why? Because they don't want it to look like a typical industrial building. So it has to be like a circular column which is aesthetically good. Also it has one advantage, that the movement of inertia in every axis is the same. So the bracing requirement in the center is less, which is taking the 50% of the tributary area of the building. Now, since we have snow load in US, it gives, we have to consider the two types of snow loading we have. One is the balanced and the unbalanced. Unbalanced snow load gives moment to the column. We know that the circular column or the hollow sections are good axial members rather than good bending members. So what happens now, the moment increase on the column, and we have to give approximately 600 mm dia, which was very difficult to procure in India. So we had to get it from outside. Now, the third requirement what they had is they don't want Z purlins, which are also a typical part of our conventional buildings. They don't want Z purlins. Why? They don't want the birds to go and nest over there because it's a fully public figure. So they want flushed box purlins, 9.1 meter span, flushed box purlins. Now, this brings to me the second challenge. The building is sloping in the length direction as well. Already we have this show for the water flow and of course for the sliding snow. We have length-wise it was also sloping. So the connection of the box purlin to the rafter web, it was difficult because in one way we have the purlin cleat, and rafter is straight, purlin is slant. So how to give the cleat from the rafter? It was a challenge to us. We will discuss in the solution section. Now, last point. This is the flush splice connection were required. Why? Because we have standing seam roof and we have flush purlins. So if I give the extended moment connection, it will puncture the sheet, and which doesn't serve the purpose of standing seam roof because there will be leakage. So this was one of the other challenges we have. This leads to this one. Now, because of the 52 meters clear span we have, after giving the center column, around 52 meters of the span is there with all the heavy loads, snow loads and everything, hanging screen loads and many other loads were there, which is giving me around 4,900 kilometers movement. For the flush connection, it was very difficult because the AIC design guide 16 is giving up to only 4 tension bolts. The references what we had available in the design guide was only up to 4 bolts, which was definitely not sufficient for this kind of movement. But as a consultant, they are asking for everything they want the reference. Now we don't have. I in fact try to give our Indian methodology, which we have from the design of steel structure from Mr. Dr. Subramanian, and one of my favorite book, which is S. Bhavikati. We have calculated the moment, we have calculated the tension force in the bolts, and we have given the calculation. But still, they wanted the exact bolt configuration which were not available. So, this was one of the biggest challenges, and it took more time to solve this. I will just explain the next section how we have made it here. This is the final requirement. What they want, they don't want the jack beam to be like a typical industrial building. Generally, what happens? The jack beam, the rafter rests on the jack beam, and the jack beam will rest on the column. This is how we give it to the building. But they don't want it that way. They want the rafter to, they want the jack beam to pierce through the rafter. This was one of the requirements. They don't want it to look as an industrial building. This is the jack beam, and this one is the rafter. The jack beam needs to go from inside the rafter. This was their requirement. Now this is of course weird for us, but we have to do it. Client is always a client. Now let us go to the solution section. The first one, wall bracing. How did we omit that? Of course the building was open, but there will be drag force in the building. So to counter that and also the secondary forces, we have given the minor axis fixed at the base. Means that there will be moment in the minor axis, which is against the fundamental of I sections. I sections are designed or made to take no moment on the minor axis. But in this case, due to client's requirement, we have given the minor axis fixed, which is giving the more bolts in the length direction. Of course, it increases the cost of the foundation. But here the client was more towards the aesthetic view than the cost point of view. So this is one of the case. Now the second solution was the building sloping in length direction and the connection detailing. How did we do that? If you see here, we had to give the slotted hole connections in every purlin connection, complete slotted holes. This brings to another design constraint, which is we have to design the connection in slip critical condition. So for all the purlins, we had to give this calculation for the connection in the slip critical condition. The third one was the connection design, which took a lot of time for us, and it's great learning for everyone, including us, that the flush moment connection required was available only for 4 tension bolts. Then, even the CNS consultant, they were not having the right references. So what we did, CNS consultant along with us, we have reached to Mr. Thomas Murray, who is the author of Design Guide 16, Design Guide 4, and AI, and many other design guides. We reached to them. We asked for the references. Do we have anything that we can do in this type of case where we have 5,000 Newton moment and we don't have the reference available? Of course, there is a big thesis that we have got, and with that, we have already we actually have to find out this why. This is the lever arm. So this why was not available for our type of connection. So if you see on the right side, this was the connection. This was the bolt arrangement was required. So the reference was not available for that. So finally, by one of the thesis submitted to Mr. Thomas Murray from one of his students, we have taken that and we have calculated the Y and got it vetted by Mr. Thomas Murray, and we have designed this connection with full reference available. This was good for us. This was a new learning for us at that time. Then the jabbing arrangement. Before going to this, I want to show one picture first. If you see this one. This I will explain you in drawing now. This is the jabbing. Now the major problem was how to weld, what to weld to which, and how to transport it. So we came with this solution. This one is one slice, this one is one slice. So this center piece is going to weld to jabbing. This way, or you can see this way. This is jabbing. We have 2 pieces weld to weld with couple of loose plates required to weld at side. This one and this one. And this green color, what you see are the stiffeners required. I will show you in a couple of pictures. In the next slide, you will see the stiffener requirement. The stiffener design was done by CNS consultant only. We have given our own design, but they were not satisfied. They have done their own stiffener design, and there is very huge length of stiffeners are there. Now, let us see the results. After all the research, what we have done, where we reached. This is the jabbing once again. This is the circular column. These are the stiffeners. You can see more. This is a Widespan building. Now if you can see, these are the stiffeners. These are the stiffeners. These are the stiffeners. That's all from my side today.